Hello folks, so we're going to move forward slightly. It's box 27, we've still got one to do from box 26, but that's a gift to me from the customer so it doesn't have to go back. So we'll put this one in and then we'll go back to that. And that's a York 861. This is set 1 of 1 and it's a Mustang CB1000. So that's made that nice and clear. We've moved on to box 27. So again, we're still in what's called Holy Week, and the trouble there is, as a church organist, I've got an awful lot of services. This is from Alan. It's a free gift from Alan. Thank you very much, Alan. Another CB for you. This one transmits no audio. Meter light does not light, but it lights red on transmit, which we do. Now this is the later type with that type of socket, because you can end up with the earlier type which has got the clippy one that you couldn't even get at the time. So these are usually really nice. So we'll unscrew it. But we'll still go through all the parameters. Oh, I've missed a screw. There were 3 in it, I only spotted 2. So we're doing church organ tunings, a church organ tuning this afternoon. That takes about 2.5 hours. So I thought, well, I've got 20 minutes to make a start on this. So has it got the right ballast resistor? Let's have a look. He's got the weedy ballast resistor and he's got a capacitor that needs changing. We'll come to that. I mean, that's only 3 watts, so you can't expect the radio to do more than 3 watts. Excellent. So we have the power leads for these, but we'll connect it with the crocodile clips. Because I haven't got one handy on the bench. So it's a Maxon 002F chassis, what's known as their economy chassis, and it's only economy because it has less available features. But it has the built-in Roger bleep for people who love Roger bleeps, which is permanently on. So we'll power up the radio. 13.8 volts. We're plugged into the test set. I need to plug in. Oh, it's got PA on this, so we'll do that as well. PA and of great sets come from Alan as well, and they'll both astonish you. I'd love to get the second one going because there's 7/8 of it there. So let's look at it. Oh, I haven't connected my crocodile clips up. go. It's come on channel. Oh, it's already hearing the signal generation we've not even set up yet. We'll switch it to PA. Testing 1 2 3 4 5 5 4 3 2 1 1 2 3 4 5. So that's working. So just get a blank sheet. I think it's a 6 today. So we'll just put X Allen, so we know that. And we know straight away the meter lamp doesn't work, and we know the PA function does. There's no mic, so let's have a look at transmit. Channel 20, switch picture in picture on. It's just doing 2.8 watts. And on channel 40 it's doing 2.8 watts, and on channel 1 it's doing 2.85 watts. On channel 20 the transmit current is 1.276 amps, and on low power it's not adjustable on these, it's 210 milliwatts, and that will come up in line with what that's doing, because we will be getting 4 watts out of this, I'm absolutely sure. So let's look at deviation. While, oh, I'm wrong scale. 1 2 while, just slightly higher at 3. And the frequency, let's put the camera onto a camera onto 79083, starting to be noticeably low. I know the test set's only been on 10 minutes, but we'll see if we can get anywhere near, because a lot of these you now can't. We can't. So we're going to have to change the reference crystal. Be nice if we could find one on a scrap set. Right, so for this we need the Amstrad manual. And I seem to remember these are a negative chassis, which is one of the things which made it a bit cheaper, with it not being a floating chassis. Could actually get to the pin we need to read. So on channel 1 it is 2 volts. Look at that, it's 1.974, so we're not going to adjust that. So we're going to transmit, and we should also have 2 volts. But we haven't, so that needs addressing. Adjusting the trimmer capacitor. It never works out right at the other end, but it needs to be right at the bottom channel, or you're going to end up with channels dropping off. So that's a bit nearer where we should be. Now on channel 40, it's supposed to be around 4 to 5 volts. Are we on channel 40? No, we're on channel 38. So we're on receive. It's in lock. It's under the 4, but it's in lock. And on transmit it's 3.65. This is one of these service manuals that you've got to take what it says slightly with a pinch of salt and use a bit of experience, which is where the lock is really supposed to be and not what the manual says. You can end up with minus voltages on this chassis. So that should have all the channels now at most temperatures. So we'll now go over back to our meter. We're not going to get far because that's going to end up having to be, I just don't like those type of resistors. It just needs changing full stop. But we'll make a start on these 3 and then we'll change that, and we'll change that capacitor, which is definitely stressed. So the first transmit coil, just making sure we're still on channel. I misread that. I've got it on 30. It's 20 it needs to be on. There's a slight adjustment there. I'm still on low power, aren't I? Start again. So just a whisker away from 3 watts there. So we'll turn the power off and we'll get that resistor and we'll get that capacitor out. I've actually had these resistors on back order for a year and some have come. Mind you, the fact they put 2 in, it sounds like they were in short supply when they manufactured these. So that's that out, and whilst that's out, it's easy to do this capacitor. Is that the pin? So what have we got there? 47 microfarads. Let's see if any of them are left. Oh, it's slightly high, so it's still working. Anyway, the pence these cost, it's being changed. So the idea here is to put in a one with a higher temperature rating, because it's right next to that resistor. So this one's 85 degree rated, which has come out, and I just think it's probably the sheer heat that's caused that to happen. And the new one's 105 degree rated, so it should be more able to cope with that. Did I check the polarity when I took it out? Well, kind of, but then I forgot. So it shows it's positive to the right. And when you look at the print, you can see that the side which we now know is negative actually goes to the earth plane. Right, so that's that bit done. And you'll see I've just put it kind of slightly to one side. I wanted away from that resistor. That transistor shouldn't be a problem. Mind you, I don't like that coil that close to it. So we've had these come only yesterday. These are the type I want to use, which is 7 watt rated. They're ceramic glazed. I mean, aren't these made in the UK? Why has it been a year coming? I just don't understand it. But all the suppliers, it's been the same. I've got them on back order from 2 suppliers, you know, in the hope of getting some trickling through. And they are. That's exactly what's happening. They're trickling through. So instead of this kind of mess here, so the one with the insulator on we'll put there. And I would suspect that we're going to be a bit nearer to 4 watts. When I was doing my church pipe organ building stroke restoration apprenticeship off the premises just off Carlton Road at Nottingham, Wireome had a factory on a parallel road, was it Stenton Boulevard, where they made just this type of product. I expect that's long gone. Right, so we'll power it back up. Might remember to put the mic in as well. So that capacitor was precautionary, it was still working. Whereas that resistor, I believe to be necessary. Well, it's necessary for it to do 4 watts. So without any further adjustments, we'll power it back up and see what we've got now. What's banging across. So it's now doing 4.8 watts, so we'll now drop that. So that coil needs to be peaked. Which it already was. And this coil needs dropping just like that to 4 watts. Excellent. Then we'll look at it on the other channels. So on channel 40 is 3.8 watts. On channel 1 is 4.1 watts. So popping it down to channel 20, we'll look at the current now, which is probably more. It's now 1.266. So by retuning it, we're getting a watt more and it's drawing slightly less current. How impressive is that? So the rest was all being wasted in those silly little resistors which are just heating up and taking the power away. Now if you ever come across these with the resistor missing because some wally thinks it's going to do 1,000,000 watts, do put the resistor in, won't you? Because you will destroy the 2166 output transistor, which are at least £16 these days for a real one. All those AliExpress ones, which are nice and bright and shiny, are fake. They're just rewritten audio transistors. So other duff suppliers as well. So it is a snag. Fake transistors is a snag, and Mitsubishi stopped making these 20 years ago. So any which are in stock are going to be looking tarnished, not bright and shiny. Right, low power is now 340 milliwatts, which is a bit nearer the 400 milliwatts it's supposed to be. So we'll do the deviation and then we'll be calling it a day. Whether or not I can pick this up later on, it would be nice, but under a lot of time pressure at this time of year. Wow, that's spot on. I got that right. That makes a change. So it's now 2.2 average to 2.5 peak, and it was RX OK, TX low, and OK stroke OK. We can't deal with that. Reference crystal out of spec. So let's just see what it's doing, because now the test set's warmed up to its expected thing. Let's see where we are. No, it's too low. So that might be the next thing. Oh, I'll do the meter while we're just here. Just do the meter. We're on low power. I love keeping this on low power, don't I? So it's supposed to be in the centre of the red zone. And that's where it now is. Right, we'll come back to this in a bit. Right, we'll restart the video. We've got the radio now. What meter do I want? Probably the oscilloscope, to be honest. I've got the front off this now. I felt that the knobs in the front were a bit grubby, so I've stuck those in the dishwasher. And while I've had to take the front off to do the meter lamp, so it seemed to be a kill two birds with one stone situation to do that. So that'll be about 20 minutes. So while we wait for that, we'll carry on with the tune-up. Oh, we've got to change that crystal, haven't we? That's another problem. Forgot about that. I'll just see where we are with the frequency, just in case it's got better over the last few hours. 79109. It's not going to get better, is it? I'll pause the video while I think of something. Right, that's going to be pretty warm. Alan kind of sent me a scrap AM set, a Maxon based one, and so that had a working crystal on it. So we'll now, it's going to be slightly warm from soldering it, and you have to be very quick soldering crystals, you know, or you can easily destroy the element inside. So what we'll just do, we'll put it somewhere near and then I'll check it at the end. So we're now 2779162, which as you can see is much higher. Let's hope it'll go low enough. Yes, it will go low enough. So we'll leave it at there, 2779126. So that's the duff crystal, that can go in the bin. So that's another thank you to Alan. The radios come from Alan, crystals come from Alan. The resistor hasn't. The capacitor hasn't. Right, so on to the receiver. Right, so we didn't jot any of this down, so we'll do now. Actually, I showed the cyanide meter while we just get somewhere. So already we're at 0.58, which is excellent. Sure, we won't get any better anyway. 0.48, and if it does 20, not 2.2. Squelch, turn the squelch to full. 100 microvolts, just where we want it. And let's check the other end. Turn the squelch to minimum. Oh, it's one of those, it never opens at all. Right, so it's one of these sets where at minimum squelch there's no hiss at all. So as soon as we put the signal generator on, it's 0.15. So that needs bringing up. So let's hope we can do that. We'll have a look at the S meter. S9 on the signal generator, and we've got 7. So what is it to get 9? It's a struggle to get 9. It's 300 microvolts. Sorry, it's 30 millivolts. I'm looking at the wrong bit. So 30 millivolts, we've done that. That was low before. Right, here goes. So we'll start with the detector. S9 signal. We'll look at 100 microvolts. We'll look at the oscilloscope, take the bench light off, and just adjust the detector for maximum recovered audio. Actually, that was a bit out, folks, as you saw. Right. So get that over to 4 dB on the cyanide meter, and let's see whether we can get a bit more sensitivity. Probably a tiny fraction there. No, that's perfect. these IFs, we want a bit more signal for those. A bit more than that. I think that was slightly lopsided. That one wasn't. And then we'll just go back to these front end ones. That's where we are. We've got a new reading. So for 12 dB, we've got 0.53. We'll get an extra 6 inches range. For 10 dB, we've got 0.46. And for 20, we've now got 1.5. Right, see where we are with the squelch. Well, I want it to open when the squelch is at minimum, not sat there like it is. Right, put it to full. So it's now 30 microvolts maximum, which isn't ideal. But on the other hand, I don't want the set to not sit there hissing, so let's see where we've got the sensitivity, because it was ridiculous before. So set that to threshold. Yeah, it's still 0.15. But I say when we've got no signal on, like now, I want it set to hiss. It's very disconcerting if it doesn't. So if you've got a lot of noise in a town, this particular set wouldn't be ideal. Right, what other switches have we got? What's that? I don't know. Is it channel 9? Oh, it's CBPA, isn't it? Yeah, all the switches work, pots work, sockets work. Haven't tested the speaker. Let's check the frequency once more, because that soldering iron will have cooled. Yeah, that's fine. There we are, that's the parts used. So apart from the S meter, that's it. So put S9 on there. And let's adjust the S meter. For S9. So now we put more signal on, we'll hit plus 30 and so on. So that's exactly what we want. So we're done. So I'm just going to have to wait for the dishwasher. Oh, meter lamp. Forgot to write that down on the sheet. It would be really nice if we can scratchy corner this today. Then we could go back to box 26 and do that York 861, and you're going to laugh when you see the front. Right, well that's the front after the dishwasher. And when you put these screws back in the side, you really have to be very careful, only just to get them snug, I think the best word is, because this has already lost one of its lugs because somebody's tightened it up too tightly. it's not far off losing the next one on this side. Imagine I've got it over the edge of the bench because of the microphone socket, so I'll show you what I mean in a moment. So it's lost the edge of the lug there. Right, we'll get these knobs on. And it's a D one, this, so you can't get it in the wrong position. That's where they want it to be. Right, so it's just a matter of putting it together. That's a bit loose. I think the speaker's probably not the original. I'll unplug these now. To replace the missing one. Good, that's worked out nicely. So now we'll put it on the aerial, which is the Antron 99, or I think ours is a Solarcon 99. There's loads of other different types of 99. One and a Roger. Well, somebody's out there, aren't they? I heard a Roger bleep. That's Skip coming through. Right, well, we'll leave it on Mega Chippy channel. We didn't hear anybody on there. So that's worked out a nice radio. So thank you for watching the Mustang CB1000, kindly donated by Alan. We'll do an on-the-air test shortly. See you on the next one.